This is the section 3 podcast of chapter 7, identifying action and reaction. To identify a pair of action-reaction forces, first identify the interacting objects A and B, and if the action is A on B, then the reaction is going to be B on A. Now, so a simple recipe for identifying action-reaction forces is first identify the interaction. Then the action-reaction forces are stated in the form: object A exerts a force on object B exerts a force on object A. Sometimes it's hard to figure these out. It's not exactly obvious what's going on. So what's the action-reaction forces in the case of a falling boulder? The earth is exerting a force on the boulder, pulling it down, and then the reaction is the boulder pulling back up on the earth. So A exerts a force on B, reaction is B exerts a force on A, action: tire pushes on road, road pushes on tire, earth pulls on ball, ball pulls on earth. And this one here is the one that most people have a problem understanding, is that when the earth is pulling on you, you're also pulling back on the earth. Here a rocket pushes the gas actually pushes the rocket forward. This is another one that people often have problems accepting. We know that the earth pulls on the moon. Does the moon also pull on the earth? If so, which pull is stronger? The pull on, it's similar. The analogy they make here is interesting. The earth and the moon both pull on each other with equal and opposite forces, and the analogy he makes here is that the distance between New York and San Francisco is the same distance as from San Francisco to New York. It's kind of a redundant question. How do you identify the action-reaction forces in an interaction? To identify the pair of action-reaction forces, first identify the interacting objects A and B, and if the action is A on B, the reaction is B on A.